Hello everyone, this is Amritpal Singh. Welcome to the next video. Guys, in this video I'll be showing you a little project on PySpark. Let's get started. First of all, I've already opened up my Jupyter notebook, so I'll be using this as a platform to discuss today's video. So first of all, let's import the necessary packages. We are going to actually do what? We are going to just do the simple taxi fare prediction using PySpark. For that, for this project, we're gonna use this short little data set in which we have just 3 columns. Okay, trip distance, passenger count, and fare amount. Okay, we are having almost 1000 rows available, so we are gonna use this little data set to demonstrate today's video. Right. First of all, let's import the necessary packages. Right, from PySpark. PySpark.sql import what? Import Spark session, which is the entry point to the Spark. Second is from PySpark, because it's going to be ML project, so we're gonna use ml.feature import VectorAssembler. So what is VectorAssembler? A VectorAssembler is nothing. VectorAssembler combines the multiple feature columns into a single vector column for ML models, right? Afterwards, we're gonna import another important thing from PySpark.ml regression for prediction system regression. Import linear regression. Right? Afterwards, for evaluation purpose, so we're gonna do what? PySpark.ml.evaluation import what? Regression evaluator. Okay, regression evaluator, right? So fine, so we have run this. Okay, sorry, I just missed here. PySpark. Okay, PySpark, right? Fine. So this is done. Afterwards, now let's create the Spark session. Spark session dot builder dot app name. You can have any app name here. I have written here taxi fare prediction. Taxi fare prediction, get or create. What it mean? If the Spark session is available, get it, otherwise create it. Entry point, right? Afterwards, let's load data set. Okay, data equal to, it's available in my D drive. So spark dot read dot csv, it's available in my D drive with the name synthetic underscore nyc underscore taxi dot csv. This is the data set location. Afterwards, we have to give the header equal to true, because the first row will be my column name. Header equal to true, and infer schema, it should infer data type automatically. That's the meaning of infer schema. There should not be any mismatch of data type, so that's why we are doing this. So just to check out if it's working or not, we can go for data.show5. Why show? Because it's a data frame. We can use show method to print. So show5, it's showing the result. It means everything is okay till now. Afterwards, now let's do the feature engineering. For that, let's apply the VectorAssembler. VectorAssembler. Okay, it's gonna have input calls. Input calls means input column. As I've already said that it's going to combine these two, because we're going to predict the fare amount. Okay, this is my target, so these two will be my features. So these two I'm going to combine into one. Okay, trip distance and passenger count. That's why input calls. So it is in the square brackets trip distance and passenger count, right? And afterwards comma output call means output column. This is going to be my feature. This is going to be it's going to be created actually, features. Okay, so to do that, what we can do, we can use transform method. Assembler dot transform. What is transform? Transform is take one data frame as an input and gives another data frame. It means it will take this data frame as an input, it's give you another data frame with the transformed output. Means you will see you will see that features will be added. Okay, let me show you. Data dot select features comma Fairmount. Okay, let me run this. Okay, final data, let me show you what we have in the final data. Dot show 5. Let's run it. You can see now this two has been combined. This is what I was saying earlier, right? This two has been combined into single column with the name features. Okay, now let's do the next step, the training testing stuff. Train comma test equal to final data dot random split. Why random split? Just to overcome the biasness. So it will select automatically any data in which the 80% will go to the training part and 20% will go to the testing part. Okay, so I'm having some issue with my keyboard, so I have to use for this bracket this one. Okay, it's my 80% and 0.2%, right? Yeah. Seed value. What is seed value? Just to reproduce the results, we have a seed value. Okay, minimize, run it. Okay, so what is going to be done, right? In this case, we are going to divide the data into two parts, training and testing. 80% go to the training part, 20% go to the testing part. Why random split? So that there will be no biasness. We don't know which 80% is going to the training and which 20% going to testing, right? Okay, that's a reason. Afterwards, now let's train the model. Okay, we're just approaching the end of this. We are going to use linear regression. Features call equal to what? Features, right? Label call equal to Fairmount. Okay, so features call, feature means this is the features which going to be sent as a input, right? So that's why we are using features call. Then we have a label call equal to the Fairmount, right? So this is we going to predict. Okay, so equal to, let's train the model. For training we are going to use fit. So the 80% train, that train data will go here, right? Okay, let's run it. So it's running fine. Afterwards, what we can do, we can now go for predictions, right? Predictions equal to LR underscore model dot transform test. we're using testing data, right? And let's see what result we have got. Predictions dot show 5. Okay, let's see. Okay, this is the point, right? 3.54 was the actual fair amount. What we have predicted 3.7. okay, 4.95, 3.87, 4.95, 3.9, 6, 4, 8, 4. It means sometime we are doing well, somewhere we are not doing well. Just to see on the graph, okay, we are going to now plot this. Okay, so we can also do one more thing. We can also print the RMSE, root mean square error. It's a mathematical term. Evaluator dot evaluate predictions. Okay, so let's print RMSE right. Okay, evaluator, okay, it's not defined. It's saying evaluator is not defined. Let me check out what's happening here. Okay, I missed here, sorry. Before that we have to evaluate the model. Evaluator equal to regression evaluator, label call equal to fair amount, comma, prediction column equal to prediction okay, and metric name, what we gonna present, like evaluate. Okay, metric name equal to RMSE. Okay, we got this 2.0975. What it means, actually RMSE, as I've already discussed, RMSE is nothing but it's a common machine learning metric which actually quantifies the average magnitude of the errors between the predicted and actual values by squaring the difference, averaging them, and then taking the square root. So in this case we are getting 2.0975. actually in this case it's not that good, okay, but it can be improved. Okay, although lower the value, like it's good, right? But we are getting 2.04 whatever. So here, because from a mathematical value, it's not that clear that what we have achieved or what our performance. Okay, what we can do, we can now print the graphical stuff, or we can get to know from the visualization that how my model has like performed, right? So for that I'm having one I've already have written one little sample code for the visualization. Okay, just to save the time, I've written on my notepad file. Let me discuss with you. Right, first of all, we are now importing the matplot. Okay, matplot is a library used in Python for the plotting the graph, right? Afterwards, whatever the predictions we have done in the first step, we are going to, because the two things are important, fair amount and prediction, so we are turning into the pandas. Why pandas, right? In this case, because in this case prediction converting to pandas is important for plotting with matplotlib, right? Because we are working with the Python, regular Python, not PySpark. That's why reason we have to convert to the pandas, right? So in this case we are doing that. Afterwards, what we are doing, it's going to create the new figure for the plotting. Afterwards, we are going to print the plot, the scatter plot, in which we are going to have the two things. One is nothing but the actual, one is the predicted fair amounts, right? So in this case there will be two different colors you will find. One is red, one is blue. In this case we are the x label will be actual fair amount predicted, and the y label will be predicted fair amount, and title will be this, and it will be going to print. Okay, what is happening in this case? In this is the plt dot scatter, meaning is going to be a scatter plot, and this is this actually indicates that we are going to have the red dashed diagonal line. You will find at the end it's go from the min actual min to the max actual, right? So in this case, if our model is good, 100% accurate, all the blue dots will fall into the red line. Otherwise, you will find your some difference between the line and the dash line with the blue dots. Okay. So I'm just repeating again. We are going to add this module to our the first step that we did on the Jupyter notebook. Just to save the time, I've already written this code here. So what is going to happen? First of all, we are going to have the because this predictions is nothing but that we got from first step. It's actually a data frame which is containing both the actual and predicted taxi fares. We are selecting both and we are turning into a pandas, because it's important is converting into the pandas so that we can use it for the plotting with matplotlib. Afterwards, this is nothing but we are giving the dimensions here. Okay, so fig size, meaning is 8:6 means width equal to 8 and 6 means height equal to 6 inches. Afterwards, what is happening here, we are going to use the scatter plot. Then the scatter plot is we are using for actual versus predicted. Alpha equal to 0.5, meaning is it is making the point semi transparent so that overlapping points are visible. Afterwards, we are doing this this stuff, min and max, meaning is it's going from min to max, right? Afterwards, if the model is good enough, you will find all the blue points are lying on the red line. Otherwise, it's going little here and there. Okay, let's do it. I'm going to copy this straight away and paste it here. Let's see if it's working or not. Okay, just to save the time. Okay, you can see this is our final output. In this case, you can see this is the dashed line, the red dashed line. This is the actual values, and this is what we have predicted. We are going little here and there. If everything was fine, if it's 100% accurate, you will find all the blue dots on the red line, because because RMSE suggests also there's a scope of improvement here. That's why we are having these points going here and there, right? So I hope from this short little video you have understood that how we can make little simple projects on PySpark, so that you can deploy your knowledge on such projects, so that you can you can present to someone and you can easily defend yourself that you know the basics of PySpark. So thanks for watching, guys. See you next video.